1 second. Does everybody have the notes? All right, really easy. So this is starting out with a lot of review. What kind of triangles do you have when you look at their side lengths? And what triangles do you have when you look at their angle measurements? You should already know this from many previous courses. Okay. The one that I feel like most people are a little shaky on is maybe what a scalene triangle. Maybe you forgot that word. Scalene just means none of the sides are the same. Isosceles, we've got at least 2 sides that are the same, and it's a little hard to see on the paper, but they are marked congruent. And then equilateral, all the sides are the same. There's some things that we will review and learn in here that, like with isosceles, it hasn't happened yet. With isosceles triangles, if two of the sides are the same, then we have these angles called vertex angles. Those will also be the same. And then with equilateral triangles, if it's equilateral, it's also equiangular, which is down here where all the angles are the same. So if it's also equilateral and equiangular triangles are always the same triangle. Okay? Acute triangle means none of the angles are 90 or above, so all of them are less than 90 degrees. A right triangle, we have one right angle. Do you guys know why we can only have one right angle in a right triangle? Who knows? Why can't we have 2 right angles in a right triangle? Can you draw a triangle that has 2 right angles? Why? Why? Lynn? Well, it's 3 sides, so, like, can we have a triangle like this? What do all 3 angles in a triangle have to add up to be? 180. That's actually in this packet, if you didn't know that from before. So if 2 of the angles in a triangle are already 90, we're already at 180. So that means we don't have a third angle, or it's 0 degrees, which is not possible. So that's why we can't have 2 right angles in the same triangle. So here's my answers that I got for the first 5. You can't see the third one, or the 5th one. Here we go. So I've got obtuse and isosceles. I have obtuse and scalene, equiangular and equilateral, a right and an isosceles, and acute and scalene. How'd you do? What'd you miss if you missed anything? Nothing? What'd you miss? Isosceles, the first isosceles? Yeah. Because of this rule right here? Because we haven't taught it yet. And if you didn't know that isosceles also means that we've got 2 angles that are congruent, that one you might have missed. Were there any others that were tricky? Just the first one? Okay. All right, the next example says we're going to classify a triangle when it's in the coordinate plane. So that means to classify it by its sides, and then we're going to determine whether it's a right triangle. Classify it by its sides, you have to find the side lengths, which we've already done in here a few times. It was actually on your weekly review last week and this week. Classify it by its side lengths, we have to use the distance formula. So the distance formula is like d equals big square root, subtract your x's, then square them, plus subtract your y's, then square it. That's the distance formula. So I'll do PQ. Remember when I write distance in geometry, we don't put a line above the PQ. That means distance. So we're going to square root. We're going to subtract our x's. So my x's are -1 and 0. And subtract the y's, 2 minus 0. So I get 1 plus 4, which is square root of 5. This side is square root 5. Nope, this side is Oh shoot, I did PO, I didn't do PQ. Sorry, that's a no. There we go. I'm sorry, I did the wrong one and I wrote it in a pen. So that's PO. Bless you, now let's do PQ. Did I confuse anybody with that one? Sorry. So we're going to do 6 minus -1 squared plus 3 minus 2 squared. So I have 7 squared plus 1 squared, which is 50. Is square root 50 simplified all the way, or does it break down? John?
Break down.
To what?
5 square root 2.
Oh,
25.
yeah. 25 to 2, which equals 5 square root 2. So this side right here is 5 square root 2. And then the third side, QO or OQ. This one's really easy. 6 minus 0 squared plus 3 minus 0 squared. So we got 36 plus 9. Is that 45? Did I do my math right? Does that break down? Okay, to what and what? Square root of 9 and square root of 5, which gives me 3 square root 5. Do you guys know, am I allowed to add up all these? Just curious what you remember from Algebra 1, if you remember anything. Are you allowed to add a square root of 2 plus a square root of 5? It's okay if you don't remember. My pre-calc kids don't remember. Can I add together a square root 2 and a square root 5? You think?
Yeah.
What do you think, Rikai? You don't know? You think you can't?
And you can multiply it.
Definitely can multiply it. You can't add it because they're not like terms. They're not the same radical. Our terms for this would be radicals. You can't add them if they're not the same term. Austin, could you get your head up, please? All right, somebody tap him. Get your head up, dear. And take your headphone out. Okay. So I'm just going to use my calculator to add these. It's going to be an approximation. It's not going to be, oh, wait. We don't even need to add them. Never mind. We don't need to add them. What do we need to do? What's it say to do?
Find the right triangle.
Oh, no. What's the first part say to do?
Oh.
Classify it by its sides. Are any of the sides the same? Then we have a scalene. So the second part says, do we have a right triangle? To determine if we have a right triangle, we need to look at the slopes and see if any are perpendicular. So that's what we're doing to determine if it's a right triangle. We need to look at the slopes, see if any of them are perpendicular. So I'm doing the slopes in a different color so you can see that it's different than the first thing we did. I'm just going to use the picture. Can we find the slope from P to O? Is it negative or positive? It's negative. And then if we go down 2, right 1, what is my slope? It's negative 2. Next one, let's do OQ. So it's uphill, so it's going to be positive. We're going to go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. So the slope for that one is 3 over 6, which is a half. And then I will look at P to Q, which goes up 1 over 7. 1/7. What do I know about perpendicular slopes? Lynn? They're opposite reciprocal. Opposite and reciprocal. Do we have any slopes that are the opposite, meaning plus minus, and reciprocals? Do you need help? Jay, do you need any help? Or do you need any help? Okay. I want to hear from this side of the room. Aaron. Do we have any slopes that are opposite signs and which, just tell me the numbers. Which two numbers? Negative 2 and 1/2 are opposite reciprocals, so there is a right angle right there. Even though it's not marked, we just proved it by finding the slopes. So yes, this is right. Okay. All stuff you've done before, just maybe in a Here's vocabulary. I'll just give you your vocabulary. If I have time today, I printed it out. I just have to run the copies. Otherwise, I'll give them to you on Friday. I'm sorry. I forgot to print that this morning. You can see how much I printed. Interior angles and exterior angles. Interior angles would be inside of the triangle. Exterior angles would be if you extend any side of the triangle, it would make an angle with another side of the triangle. So in my first picture, I will show you some exterior angles that are at point B. Exterior could be this one, and it could be this one. It's not going to be the angle that connects the two extended lines. It's going to be these two angles. Here's another way to think about it. They are a linear pair with an interior angle. What does that mean if they're a linear pair? They share the same side, they both make a line of the other side, but what also does it mean? What do you think, Ebony? Oh, they're supplementary. They add up to 180 degrees. Perfect. And what kind of angles are these, by the way? Vertical angles. And what do we know about vertical angles? Those are congruent also. So we'll have two exterior angles for every one interior angle. Triangle sum theorem, you should already know this. If you add up all the angles, it equals 180 degrees. There is a proof for this. We're not doing the proof today. Oh, I know you're sad. Here, right? Right? Yeah, that's what I thought. Okay, and then we have something that you may not have done before. This is called the exterior angle theorem. The measure of one exterior angle of the triangle is equal to the sum, is equal to the sum of the two non-adjacent interior angles. So in this picture, the measure of angle 1, which is out here, is equal to adding together angle A and angle B, which are not touching angle 1. So if I need to find angle 1 really quickly, I can just add A and B together. Or, yeah, I guess that's about it. So finding an angle measure, we need to find the measure of angle JKM, this angle. Well, I have an X for J. I've got 70 degrees for L, and outside here, and the one I need to find is 2X minus 5 degrees. So we're going to have to set up an equation. So according to our exterior angle theorem, the exterior angle, this one here, is equal to the sum of the other non-adjacent interior angles, x plus 70. So now we just have an equation we can solve. When we have x's on both sides, you need to subtract the x to get them all on the same side. Add the 5. Here's our answer, 75. Why not? That's only the x, and I was not asked to find x. I was asked to find measure of JKM. So we're going to have to plug that 75 back into 2x minus 5. 2 times 75 minus 5, which is 150 minus 5, which is 145 degrees. Please put a degree symbol when you write degrees. Okay? Is our brain working way too hard right now? Oh my gosh, we're on the last page already? We have never seen a corollary to a theorem yet. A corollary is a statement that can be proved easily using the theorem. So the corollary below follows from the triangle sum theorem. So this has to do with the triangle sum theorem that says all angles add up to be 180 degrees in a triangle. So we have all the time for a shortcut. You don't have to use this theorem, but it's like a time saver. So if you have a right angle, this is just if you have a right angle, then the other two angles always add up to be 90 as well, because the whole thing has to be 180. If that 90 is this one, the other two have to equal 90. So if I'm trying to find a missing angle, let's say I know this one is 30 degrees and I have to find this one, I don't add 90 plus 30 and subtract from 180. That's a lot of work. I just know that these two have to add up to be 90. So I go 90 minus 30 is what, guys? 60. What did you say? She's just taking it back. Okay. I say wrong things all the time. You hear me and you see me, and if we got video evidence of it, which is even worse. All right, so that's the corollary. If it's 90 degrees here, you just have to take this one from 90 to find it. Modeling with mathematics. We have that's outlined here. It's kind of hard to see, so I'll outline it even more. The measure of one acute angle. Oh, it says it's a right triangle, sorry. Measure of one acute angle in the triangle is twice the measure of the other. Find the measure of each acute angle. Do we know either of these angles? Austin, do we know either of these angles? Do you know the measurement of either of these angles?
90.
Oh, that one.
Yeah, you know all of them.
How do you know it's 45?
Oh, wait, no, the other two add up to 90. It's not 45.
They could be.
That one's 90.
This one's definitely 90. Stephen, do you know? Or are you working something out?
60, 30.
So how'd you find that?
1/3 of 90 is 30, and 1/3
So you were thinking if one of them's twice the other, that's kind of like 3 times the same number, okay? And then you found the answers. That sounds great. I'm going to show you algebraically how we can do this if it wasn't such an easy answer, okay? So here, I don't know either of these angles. Let's give one of the angles a variable, okay? So how about x is going to be the measure of one angle, acute angle. And this says the measure of one acute angle is twice the measure of the other. So how can I find the other one? I got 2 right answers that could be yelled out. 2x, that's one right answer you could have yelled out. Does anybody know the other right answer? Could one of them be x and the other could be a half x? If one of them is twice the other, then if you switch it around, isn't one of them half the other? Yeah. So you could do it either way, but I'm gonna go with the not fraction. So if I add together x plus 2x, what should they equal? They do equal 3x, but that's not what I meant. Like, that's my next step. Simplify. What would they equal number-wise? 90. Because the other 2 angles, the acute angles, are going to add up to be 90. So 3x equals 90. This is exactly what Stephen was saying. Divide by 3. We get x equals 30. Then I plug it into here. 2x would have to equal 60. My answers are 30 degrees and 60 degrees. So that's algebraically how you could attack that situation. Then the last two, find the measure of angle 1. Well, what do you know about angle 1? Oh, no. There's actually a couple ways you could set this up. What could we do for angle 1? Nobody knows. Come on. Jesse.
You would have to do, would you do the 5x minus 10 too? Would you do it with the 40 plus 3?
Yes. That is one way of doing it, yes. There's another way we could have done it. Aren't these supplementary? Actually, does that even help? That one wouldn't even help. Never mind. Just kidding. Don't do it that way. Okay, so then we're going to have to move the 3x over. We get 2x minus 10 equals 40. Add the 10. I'm doing this part fast. 2x equals 50. X equals 25. Is that what I need to find? No. What do I need to find? Okay. So I could plug in x either into 3x or plug it into 5x minus 10. There's two different ways you could find it. I'm just going to plug it into 5x minus 10. So be 125 minus 10, which is 115. And if this one's 115, how do I find angle 1? Right, 180 minus 115, because they're supplementary. What is that? 65 degrees. Measure of angle 1 is 65 degrees. Okay, and then last question, where these numbers are, but I think we can kind of guess that these are the two angles that are not marked 90. How could I find the measure of each angle? What can we set up algebraically? Matthew.
Because it's a right triangle,
Mhm.
the one, yeah, it's going to be 90 degrees to the 90 degree to the right.
Right. I need to set up an equation to solve. What equation could I set? There's a corollary to the triangle sum theorem right on the same page that might help you.
Oh, yeah. So, both 2x plus x minus 6
What is that? Thank you. And so 2 times 32 and 32 minus 6 would be our two answers. What is this? 64 and I can't do math this fast. 26 degrees. And you can check they add up to be 90, so we're good. The assignment is on big ideas. Big ideas. And you have your weekly review due Friday. You like it because of that? Mm-hmm. I like it, but then also you can't see the work. So sometimes